Okay, in this video I am going to go through a very involved problem. That's going to be pretty much the most involved problem from Chapter 2. And it is, well, one of the most. And it's going to set up something that we're going to do in Chapter 3 where we're going to start using two charts. Okay. So what we're going to do is we're going to have two balls. Ball 1 is thrown up with VI is equal to 20 meters per second. Ball 2 is thrown up 2 seconds later with VI equals 15 meters per second. When and where do they meet? Okay, so we're going to need two charts. We're going to need a chart for ball 1, and that's going to be X, T, VI, VF, A. And we're going to need a chart for ball 2. X, T, VI, VF, and A. Now, the one thing we know right off the bat is because both balls are in free fall, their accelerations are both going to be 9.81 meters per second squared. And we know the initial velocity of ball 1 is 20 meters per second. Initial velocity of ball 2 is 15 meters per second. And I can tell you right off the bat, I'm not going to care about their final velocities. Now, this is where we have to do a little bit of thinking. I don't know the time that it takes B1 to go from when it is launched to when it meets ball 2. So whatever that time is, I'm going to call it T. Now ball 2, from the time that it's launched to the time that it meets ball 1, is going to be 2 seconds less. So B2 is going to be T minus 2 seconds. Now here's another interesting thing. Ball 1 goes, and then ball 2 goes, and then they meet. Well, when they meet, that means that their X positions, they started off with the same X. They're going to end up with the same X. So they're going to travel the same overall distance. From where they start to where they end is going to be the same. So ball 1 is going to go a distance X, and ball 2 is also going to go a distance X. Now, let's set up the equations for B1. The equation that I'm going to use is going to be X equals VIT plus 1/2 AT squared. And I'm going to plug in what I know. X is equal to 20 meters per second T plus 1/2 negative 9.81 meters per second squared T squared. And now what I'm going to write for B2 is going to be almost identical. So now X is going to be 15 meters per second. T is going to be T minus 2 seconds. This is going to remain the same for a second here. And then again T, instead of T, it's going to be T minus 2 seconds squared. Alright, now because this x is the exact same as this x, I can set these two equations equal to each other. So down here I'm going to write 20 meters per second t plus 1/2 negative 9.81 meters per second squared t squared is going to equal 15 meters per second t minus 2 seconds plus 1/2 negative 9.81 meters per second squared t minus 2 seconds squared on the outside there. Okay, now I'm going to start distributing and simplifying and doing what I can. That's as simple as that can go. So that stays like that. 1/2 times negative 9.8, I'm going to call that negative 4.9 meters per second squared t squared. I'm going to distribute this like that, so it's going to be 15 meters per second t minus 30. Now it's going to be meters per second times seconds, so the seconds are going to cancel, so that's going to have units of meters. Now this is also going to be negative 4.9 meters per second squared. Now this, I'm going to have to FOIL that out. I'm just going to leave it to you that you know how to FOIL it out. I'm not going to take the time right now. T squared minus 4 seconds t plus 4 seconds squared. Okay. I'm going to rewrite this really quickly just so I have it. Now I'm going to distribute this into that, and so I'm going to get 4.9 meters per second squared t squared. This times that is going to give me plus 19.6 meters per second t, and then this times that is going to give me negative 19.6 meters. Okay, now I'm going to start canceling stuff and combining like terms. That term right there is going to cancel that term right there because they're identical. I'm going to take this term and this term, and I'm going to subtract off 20 meters per second t from both sides. So my whole left side is going to be 0. And if I look at my meters per second terms, I'm going to have 15 minus 20 plus 19.6. So I'm going to get 14.6 meter per second t is going to take care of this term, this term, this term, and that term. And then I'm going to combine those to get negative 49.6 meters. I'm going to add 49.6 meters to both sides. Whoop. Sorry. And finally I'm going to, so now going over here, I'm going to have 49.6 meters is equal to 14.6 meters per second t, and that is going to give me t is equal to 49.6 divided by 14.6 is going to be 3.4 seconds. So they are going to meet 3.4 seconds after ball 1 is thrown, and 1.4 seconds after ball 2 is thrown. And your job is going to be to figure out what X value they meet at.